All right, so today we're working on converting and evaluating logarithms. Logarithms are just another way of writing exponential functions. We did a whole unit on exponential functions, so we're going to find that this is not really any different, just another way of writing it. All right, so first things first, we need to talk about all the pieces. So x is the exponent of the power. We're familiar with this from exponential functions, so b to the x power. All right, in our logarithmic function, the x actually goes to the right side of the equal sign. B is the base. Again, we're familiar with exponential functions. Our base in logarithms is actually down here. It's a subscript next to the log. So we actually say the log base B. Y is the number that the power is equal to, which sounds a little weird, this definition, but read this. B to the power of x is equal to y. All right, so that's how that definition came about. So when we read this, the logarithmic form of this, we say the log base B of y equals x. All right, so the first thing we're going to do today is we're going to look at how do we convert from one form to the other. So let's go from logarithmic form to exponential form. Clean up a few of my marks here so we can see exactly what we're talking about. All right, so to convert from logarithmic form to exponential form, we got to get all the pieces in order. Do you see, looking up here, that basically our x and our y have changed places? And then we have the addition of this word log. All right, so we're going to go from log to exponential function. So we're going to switch these two places, and when we switch those two places, this x piece becomes an exponent and the word log goes away. All right, so let's do that. So switch those two places. 4, 1,296. The 4 is the x, so it becomes an exponent, and this is 6. So 6 to the 4th equals 1,296. Let's look at b. Again, switch them places, log goes away, this number becomes an exponent. So 8 to the 5th power is 32,768. Let's look at c. Switch them places, this is an exponent, this goes away. So 7 to the 3rd power equals x. One more time, switch them places, this is an exponent, this goes away. 8 squared equals 64. Oh, and hey, this one we know is true, right? All right, now we get to go back the other way. Write the exponential equation in logarithmic form. All right, so we're just going to undo what we just did. So we switch these back, and when we switch them back, this becomes the subscript and our word log comes in. So the log, make your 7 a subscript, base 7 of 343, because we're switching them places, equals 3. Let's look at f. Switch them places, this goes down. So the log, base 5, switch them places, of 125 equals 3. G, once again, switch places, subscript. So the log, base 4, switch them places, of 16,384 equals 7. Last one. Switch them places, subscript. So the log, base 2, switch them places, of 32 equals 5. All right, and that's really all there is about converting them back and forth. All right, so if we're going to evaluate, if we're going to simplify each expression, we want to get this in a form where we can do something with it. I don't know what to do with this. The log base 3 of 27, it's what? Yeah, I don't know. All right, so we're going to convert this into exponential form. But in order to convert it to exponential form, I need to have an x. All right, I need to have something here on the other side of the equal sign so that I can actually switch them places, right? So we don't know what it equals. So we're going to plug in an x. All right, now we can do this. Remember, switch them places. This becomes an exponent, the log goes away. So 3 to the x power equals 27. Hey, and this one we can actually figure out because 3 to what power equals 27? That's 3 to the 3rd. So we can actually say x equals 3, or we just say 3 to the 3rd power equals 27. All right, let's look at this one. Same thing, equals x, trade them places. This becomes an exponent, log goes away. So 2 to some power equals 128. More on this later. Oh, what about k? Do my rules change when I have a fraction? Nope. So equals x. Once again, switch them places. This becomes an exponent. The log goes away. So 3 to the x power equals 1/27. All right, and this one we can actually solve if we think about it. Remember over here, we said 3 to the third equals 27. Well, I still have 27 here. So my trick now is, how do I get this 3 to the x power to the bottom of a fraction? Y'all remember back when we did the exponent unit, we said that anything to a negative exponent, you flip it to the bottom. So if I were to say 3 to the negative third power, I'd have to flip that down to the bottom of my fraction, and that would give me 1/3 to the third power. Oh, hey, look, that is equal to 1/27. All right, then let's look at L. Once again, is equal to x. Switch these places. This becomes an exponent. So 16 to the x power equals 4. Once again, more on how to solve these in a later lesson. All right, number 2, step 2 here. Basic properties of logarithms. These are shortcuts. These are things that you get to look at and you get to say, ha, I know this. This is not going to trick me. All right, so notice on this first one, the log base b of b. Anytime your base and your y value are the same, your answer is 1. All right, and let's look at this. Let's convert it to an exponential form so that you can see how this is true. Remember, when we convert to an exponent, trade these places, this becomes an exponent. So b to the first power equals b. You remember the properties of exponents? Anything to the first power is itself. So if it's 70 to the first power, it equals 70. If it's 2 to the first power, it equals 2. If it's 5,280 to the first power, it equals itself still, 5,280. So anytime you see that your base and your y are the same number, it's going to equal 1. All right, next property involves a 1, but this says anytime you have a 1 in the y's position, the answer is 0. All right, that can be a little confusing. Let's convert it to an exponential form and we'll see why it's true. Remember, switch them places. This becomes an exponent. So b to the 0 power equals 1. Remember our exponent rules? Anything to the 0 power equals 1. Once again, whether it's 70 to the 0 power, that's 1. Whether it's 2 to the 0 power, that's 1. If it's 5,280 to the 0 power, it's still 1. If it's 10 million to the 0 power, it's still 1. So anytime you see a 1 in this place, does not matter what the base is. Doesn't matter. If you see a 1 here, your answer is 0. All right, so let's look at M. The log base 8 of 8. Oh, our base and our y match. That's this rule. So my answer is 1. Look at O. The log base 12 of 12. Oh, my base and my y match. This property again, this answer is 1. Let's look at N. The log base 1/2 of 1. Oh no, what do? I haven't learned how to do a base of 1/2. All right, chill. This one, it does not matter what the base is. This is in here specifically to see if you're paying attention to your properties. This is the important number here. This is a 1. And our rule tells us anytime, doesn't matter the base, regardless of the base, if I've got a 1 in this y position, my answer is 0. Likewise, looking at P. Log base 4 of 1. Aha, I have a 1 in that y position, my answer is 0. All right, so make sure that you're paying attention to these rules. Let me erase some of my markings here so you can see them more clearly. All right, now let's go down. The last thing we're talking about today is the common logarithm, which is a logarithm with a base of 10. All right, this is the logarithm that your calculator thinks in. All right, if you look at your calculator, you're gonna see it's got a button that says log, L-O-G. No base, no nothing here, just the word log. All right, and that's because we have an understood rule in math that says anytime you have the word log without a base, it's understood to be base 10. In fact, we could say that this is a ninja 10. Why not, right? We have ninja 1s, we have ninja 2s when we're talking about radicals. With logarithms, we've got a ninja 10. All right, so anytime you see the word log without a base there, it's understood to be base 10. And we just plug it into our calculator to evaluate. So literally, for m here, I'm going to push the log button on my calculator and then the number 8 and hit equals. And that tells me that my answer is 0.903089987. All right, for the purpose of this class, 3 decimal places, please. So my answer here is going to be 0.903. Let's do n. The log of 6.213 equals 0.793. The log of 6 equals 0.778. And the log of 110 equals 2.041. All right, and that is actually it for the day. If you have any questions, be sure to send me an email or a message through Canvas. Have a great day.